tell me about string theory.
Okay, so for you and for Ryan Macy, who suggested it in the first place, this is string theory. I'm going to go for the very basics of string theory because it's quite complicated and long. I don't have very much time because these are shorts. There are two main theories in physics at the moment. There's general relativity, which deals with really big things, like planetary gravitation, and there's quantum mechanics, which deals with really small things, like subatomic particles and how they interact. There are four fundamental forces. Gravity, which is dealt with by general relativity. There's the weak nuclear force, which is radioactive decay and things like that. There is the strong nuclear force, which keeps particles together. And there's electromagnetism, which is electromagnetism, as I imagine. I'm not going to explain that one. Currently, they're all four separate things. But what string theory wants to do is to make them all one. So, because they're the fundamental forces and they're the same everywhere, they want to make them one so it all makes sense. The basics of the string theory is that if you look into things, you get on a microscope, like really small. Look at this now, it's just a painted door. You get closer, you can see the paint, you can see the molecules, and then you'll see the atoms next. If you keep looking, you see the protons and the electrons and the neutrons, then the quarks if you keep looking harder. And what string theory says is those are made up of actually little strings.
The quarks are made of strings.
Little strings. So they're one-dimensional objects, and what these do is they vibrate or oscillate in a way that makes up these particles. So I'm going to use this as an example. In the same way a musical string would vibrate, so right now, it's out of tune, I do apologise. That makes that noise. If I shorten it, I put my finger here, it makes a different noise. In the same way, these oscillate to make different particles. And that's the basics. That's the basics of them. They've got mass, they're one-dimensional, and they oscillate in different ways to make different things. Now, another thing it has is that it doesn't work in 3 dimensions. As you know, what we have now, what we can see, are 3 dimensions. So you've got height, width, and length. Okay, that's length. So distance. It has to, for string theory to work, that has to be 10 dimensions. Otherwise, the equations don't make any sense. What we have, the reason that it's 10, we have 3 dimensions. So height, width, and then backwards and forwards. The fourth is time,
right,
or duration, and there are 6 more that we can't see, making 10.
How do you know they exist if you can't see them?
The equations only make sense with those things in them. So if it's correct, there must be 10 dimensions. The reason there are 2 main reasons they think we can't see them. One is that they are so small and all rolled up together that we just can't see them. They're too small for us to see. Another is that we're stuck on a 3-dimensional plane with duration, and we cannot get to the other 6 dimensions. I know.
Whoa, you blew my mind, Amar. This is like Futurama stuff, isn't it?
Yes.
Yes.
So yeah, those are the basics of string theory. There is a lot more. I'd recommend going on lots of websites to find out. But those are the basics of string theory.
Great, thank you, Amar.